Okay, welcome back to our Chem 4 review for the final. And we're up to part 10, I think it's still chapter 12, on colligative equations, part 3. And you'll remember, whenever you add a solute to water, three things change: the boiling point, the freezing point, and the osmotic pressure. This section now we're going to work on formula for osmotic pressure. You know that water flows from a more dilute concentration that has more water to a solution that will have less water. When it evaporates first, it creates a pressure, and that brings the water into the less dilute side. Osmotic pressure is the amount of pressure that you need to stop that flow. That's what we're calculating right now. To stop osmosis. The formula for osmotic pressure is this pi sign. That's osmotic pressure. We're going to calculate that in atmospheres. The formula is I, molarity, not molality like the other ones, universal gas constant, and temperature in Kelvin. The universal gas constant, it depends on whether you have Dr. Fainsberg or not, because then you'll have many more numbers. But for our purposes, it's going to be 0.0821 liter atmospheres per mole Kelvin. Kelvin now is also something different. To figure out, change from centigrade to Kelvin, take your degrees centigrade, whatever that number is, and add 273.15. So let's look at our problem. A 0.569 molarity solution at 37 degrees centigrade. We have that solution. If the R, and they gave you that in the problem, is 0.0821 liter atmospheres per mole degree Kelvin, calculate the osmotic pressure. Well, we already have the formula. Let's see what we can plug in. What is I? Oh, they didn't even give us a compound. All right, so let's say the compound is glucose. We know that's not a strong acid or a strong base. It doesn't have an oxyanion in it. It doesn't have an NH4 salt. And if it's not any of those things, then the I is going to be equal to 1 because glucose does not separate into positive and negative ions. It stays whole. So I is equal to 1. Molarity is what we need next. So you know the formula for molarity. Molarity equals, it's got moles in the front, so we know it's moles on the top. Number of moles of solute per liters of solution. Oh, we don't have to figure it out at all. Look, they gave it to us. What a nice problem. All right, so we don't have to calculate molarity. So our M is 0.569 molar solution. We know R, they gave us R, and I gave you R too. 0.0821 blah, blah, blah. Now temperature. They tell us the temperature is 37 degrees centigrade. That's a red flag. Be careful. You don't want to blow a problem because you didn't get the right Kelvin. So we're going to change centigrade to Kelvin by taking our 37.0 and adding 273.15. You're going to add these first. So what do we get? We get 0.1501. That's 310.15 Kelvin. Remember, Kelvin has no degrees. It's just Kelvin. When we multiply all of these numbers, we get 14.486622624 atmospheres. Remember SUN. Significant figures, units, and number. We have our number, we have our units, it's a pressure, so atmospheres. We need significant figures. For significant figures, always go back and look at the number of significant figures in the problem. What did they give us? 0.569 has 3 significant figures. 37.0. 3 significant figures. 4 significant figures. Always use the least number of significant figures when you're multiplying or dividing, which is what we're doing, 99 times out of 100. 3 significant figures, 1, 2, 3. Since the number after our last significant figure is higher than 5, we're going to round that 4 up. So we have 14.5 atmospheres. Now this was not hard because we already know how to figure out molarity and everything else they gave us. But I want to give you a warning about something. I have seen osmotic pressure problems where they ask you for this. Instead of asking you for osmotic pressure, they ask you for molar mass. Now that's really nasty, unless you remember our lifesaver equations. Remember, number of moles, lifesaver number 1, equals the mass in grams divided by the molar mass. As soon as you saw molar mass, you should have thought lifesaver. So here's our formula. The problem is asking for molar mass. Let's play with this formula a little bit. Molarity, let's plug something else in, is moles over liters. This is where our lifesaver comes in. Moles. For moles, we can plug in mass over molar mass. And that whole thing is divided by liters of solution. That's what we started off as molarity, and step by step, we didn't give up or panic. We kept going and playing with our formula until we figured out how to get molar mass. So you plug all your numbers in, and the only difference is, at the end of this pain in the neck problem, you're going to solve for molar mass. Don't forget your lifesavers. Write them on your scrap paper as soon as you sit down for the final. Our 2 lifesaver formulas, moles equals mass, or grams that you have, over molar mass. And our second lifesaver formula, density equals mass over volume. As soon as you saw molar mass, you should have realized, I'm drowning, I need a lifesaver. Okay, so we're done with our colligative properties, and we'll be back with Henry's law.